Good afternoon, everyone. Today we are going to discuss about One Island East, which is a case study of BIM implementation project. We will first give some background information of the One Island East project, then discuss the scope and application of BIM in it, followed by the evaluation of BIM adoption, and lastly, to give some suggestions towards the implementation. One Island East is a Grade A office building located in Quarry Bay. Throughout its construction life cycle, all the parties involved were required to make use of Digital Project, a software to create the building information model. The result is significant. The project was completed quicker, cheaper, and better than expected. BIM has been adopted in mainly two stages, the design stage and construction stage. In the project, BIM serves three major functions, which is visualization, file sharing, and interoperability of information. For visualization, BIM helps to visualize the whole structure in three-dimensional model in design and construction stage. All the stakeholders can have a clear understanding on the building structure. Therefore, it could facilitate communication and hence reduce misunderstanding between parties. Besides, contractors are able to submit a more reasonable bid based on the distinct tender documents and working procedures. In regard of file sharing, project-related parties are able to develop and share BIM models over the Internet during the design and construction stage. They can access to the files and collaborate together in the virtual project office at any time and anywhere. Also, hyperlinks connecting to individuals, manufacturers, or design teams are contained for each element, which enable instant collaboration as well. For interoperability of information, in simple speaking, BIM connects 2D information such as paper drawings, Excel spreadsheets, and construction schedules with the 3D model. This saves time and reduces manual error when professionals interpret the data. It could also ensure consistency between all documents. Apart from the general application of BIM, it also contributes in design stage specifically by automatic quantity takeoff and clash detection. The BIM model could generate quantities according to the HKIS format. The information of quantities is so detailed that it includes its specification, dimensions, and lists in a proper and clean format. In addition, the material schedules can be updated automatically when the design changes. As a result, cost consultants are able to estimate material costs in shorter time accurately. In addition, the built-in clash detection function of BIM allows physical design conflicts to be discovered in design stage. In this project, around 2,000 clashes were identified and resolved before tendering. This function prevents consequential loss in time and materials caused by the late discovery of clashes. BIM also helps in construction stage by construction sequence modeling and on-site information provision. Construction sequence modeling greatly enhances the effectiveness of construction process. It provides construction sequencing with work breakdown structures and could illustrate construction schedules with time frames. Moreover, it could compare different construction sequences and methodologies. Therefore, contractors could understand the time required for alternatives and allowed better trade coordination. As mentioned, the model also provides sufficient on-site information for various types of workers. For instance, the location of works, material use, and dimension of building elements. Workers could understand this information easily and prevent misunderstanding, thus lead to minimization of possibility to reworks. In general, there are three major benefits by adopting BIM in a project as reflected in the case study. Reduction of project time is achieved by three aspects of BIM adoption. Construction time can be shortened as clashes can be detected before the commencement of construction stage. Secondly, the optimal path in fulfilling the project requirements is revealed through the 3D simulation of BIM. In addition, the integrated database reduces communication time between various parties with this co-working space. The second benefit for the BIM adoption in this project will be the accurate cost estimation. Digital quantity takeoffs is adopted in the preparation of tender documents. The increase in accuracy of the estimation encourages more contractors to have bid as the price is more certain. Moreover, when changes exist after the project commences, the cost can be updated instantaneously for forecasts. The third benefit will be the risk reduction. In this case, more than 2,000 clashes are successfully located. Besides, an integrated user interface of the application can also facilitate coordination between different parties and to avoid future claims. At the same time, the accurate tender price estimation by the modeling can be a useful means in avoiding dispute related to project costs. Despite the advantages of BIM adoption in the project, there are still some limitations of the implementation. For the control and authority of information, dispute could be resolved on whether the clients or the contractors own different data of the model, as it is a valuable resource for the upcoming projects. Moreover, mistakes made in data collection will bring huge influence on the project. Without proper negotiation of the responsibility prior to the commencement of the project, disputes may rise frequently. BIM development may not be very mature currently. Regarding the virtual prototyping education system nowadays, there are insufficient reference materials in the market, which result in a low number of skilled manpower available. Also, the choices of suitable contractors will be limited. This reduced clients' willingness in adopting BIM for new projects. After evaluating the BIM adoption in the project, a few suggestions will be given. Regarding the One Island East project, BIM is suggested to use in operation and maintenance stage as well. Building information can be obtained and maintenance schedule can be created. Similar to other stages, component requires maintenance can be located easily, and the annual cost can be estimated conveniently. For the future implementation of BIM, standardization is encouraged. Currently, many problems occur due to the lack of common language for information sharing through BIM. With a standard and a guideline, a consistent presentation format can be formed, just like the one provided by the EMSD to regulate related BIM submission. As a result, misunderstanding can be avoided and facilitate processing of mass information. So this is all we want to share about One Island East and BIM implementation. Thank you.